Hi everybody, this is Mr. Folly, and welcome to Podcast 2.2. This is actually both of us. Both! For the periodic table, we're going to learn about periodicity, the definition of it. We're going to figure out the trend for atomic size and why. We're going to locate metals and nonmetals, and we're going to find lanthanide metals, actinide metals, and transition metals. So let's go ahead and get started. It's the 16th of the month, so guess what? Teen Vogue magazine is coming! The 16th of February, Teen Vogue magazine. 16th of March, Teen Vogue magazine, etc., etc., etc. And Eden is so happy because she's the biggest Demi Lovato fan that ever lived. So magazines are called periodicals, right? And periodical means repeating. So here's what you really need to write down. You didn't need to write down that. Periodic means repeating. Periodic means repeating. Periodic means repeating. Periodic means repeating. The periodic law says when atoms are arranged by atomic number, trends will repeat. Okay? So that means I'm arranged by atomic number, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So what happens here is size. This right here is big, and then down here is small. And the next row, big, small, big, small, big, small. So as I get, every time I get here, it repeats big, and then it goes small. Big, and then goes small. Okay? So when I do that, so you need to know size, big on the left, whoa, small on the right. And then, of course, it goes from big to smaller. So if it starts out being this big, big, so you get the idea. I guess I've done that probably too many times now. Charge. The charge for hydrogen is +1. Charge on helium is 0. Lithium is +1. Beryllium is +2. Boron is +3. Carbon is 0. Nitrogen is -3. Oxygen is -2. Fluorine is -1. And neon is 0. +1, +2, +3, 0. -3, -2, -1, 0. +1, +2. I think you see the trend. We ignore these for a while. +3, 0. -3, -2, -1, 0. Did you draw a periodic table to show size? I hope you did. If you did, you're a good student. If you didn't, you'll draw one now because you're a good student. Did you draw another periodic table and label it for charge? If you did, you're a good student. If you didn't, you're doing it now because you are a good student and you don't have to write down that Vogue rhymes. Periodic means repeating, so these trends will repeat. These aren't the only trends that repeat, but the ones we're talking about. Atomic size is periodic, so again, we start big, and then it starts to get smaller and smaller and smaller as you go. Okay. As you go down, it gets bigger, so bigger. See how it's a little bit bigger than the one above it, but it still gets smaller, right? So as you go down, so now you have to know why. Here is the why. Why? As you go down, there are more energy levels, so the atom gets much, much bigger. Remember how this is the nucleus? Then I have an energy ring right here, and then I have another energy ring right here, and then I'll have another energy ring. So every ring, of course, makes it bigger and bigger and bigger in the Bohr model. And it's true for the quantum mechanical model, but they're just not as pretty as rings. As you go across, there are more protons with the same energy level, so the pull from the atoms crunches them closer. So if this is like +10, and my electrons are out here, and this one is +11, my electrons would be a little bit closer because the nucleus is more attractive. So the more attractive the nucleus is, it will pull in the electrons a little bit more. Kind of like you sit closer to your friends. You're attracted to your friends, you sit close to your friends. In a lunchroom, you sit at the same table or next to them. Okay. So for the same energy level, you need to make sure you include the same energy level. That energy level is like a ring. So the pull makes the atoms scrunch in closer. So again, if you love your mama or your friends, you stay closer. If you're the 25th kid in a class of 24, you're way far away in the hallway. Right? So if we don't have enough desks for you, where do you have to sit? Out in the hall. So sad. Here's the classroom. Yay. Here's all a safety shower, of course. Here are all of our desks. But why is someone over there? Oh no, here's Sydney. stuck out here in the hallway. No room for you. Regions of the periodic table. You should know this. Your periodic table, if you don't have one, you have to get another picture and print it, copy and paste it, has a stair step on it, okay? Everything on the left is a metal. Here are my metals. Whee! Aluminum is a metal. The things on the stair are not. Whee! These are metals too. Okay? Those are all metals. Okay? Non-metals, I'm going to put X's on. Wish I picked something easier to write than an X. Ah. Hydrogen's a non-metal. And then my metalloids, oh, I don't know what I'll do with them. Oh, I can change my color, can't I? Watch me go all kinds of high-tech on you. Look at this. Woo, I colored them blue. How pretty. These are my metalloids. Anything with two sides on the stair. Okay. And then there was another, there was another group that you should know. These are your transition metals. So the D block are the transition metals. See, labeled here, transition metals. And the F block actually has two different names. This is the lanthanide series. And the series goes across. And this is the actinide series. And this sounds like weird names you can't possibly remember, but 55, 56, 57 is lanthanum. The lanthanide series follows that. 87, 88, 89 is actinium. That's why the actinide series follows that. You need to know the properties of metals and nonmetals. Metals are lustrous. That means shiny. Lustrous. And I'm just going to say not. They are ductile, which means they can be turned into wires. What's called drawn into wires. No, not. Metals are malleable. That means if you hit them with a hammer, they will bend. And nonmetals are brittle. Metals react with acids, most of them. And that was all react with acids. And nonmetals don't react with acids. What else am I forgetting? Oh, conductors. They conduct heat and electricity. And nonmetals don't. Isn't it weird that nonmetals basically are defined by what they do? But that's good. Okay. And then the next slide talks about semi-metals. Nope, they don't. So let me hop right back to that. And you have to write this down. Oh no, don't die on me. Oh no, you're dead. There's a part 2 for real of this one. So come join me for part 2. Toodles.